Number 22. Two children fight over 200-gram stuffed bear. 25-kilogram boy pulls to the right with a force of 15 newtons. The 20-kilogram girl pulls to the left with a force of 17 newtons. Ignore all other forces on the bear, such as its weight. So a quick simplification. There's the teddy bear to the right. 15 newtons to the left. 17 newtons. So they say ignore all other forces on the bear, so we ignore all other forces on the bear. They give us the mass of the boy and the mass of the girl. I don't think those are relevant really at all. And then they tell us that the bear has a mass of 200 grams. We're going to have to start getting used to or being okay with converting from grams to kilograms. Grams to kilograms is a difference of 1,000. Ooh, don't know what happened there. So I'm going to say here that the mass is 0.2 kilograms. At this instant, can you say what the velocity of the bear is? Well, we have a couple of issues. At this instant, well, no. To know the velocity of the bear, total force equals m times a. There's not a velocity in there. If we knew, or if we go with a equals vf minus vo over delta t, or for the calc folks out there, if we said a equals dv dt, those are true statements. But to know what the velocity was at any instant, we would have to know a time value and one of these other velocities. So we simply don't. So letter A, no, we can't. Letter B, at this instant, can you say what the acceleration of the bear is? If so, what is the magnitude and direction of the acceleration? This is a question now where we need to make sure we're doing things appropriately. And one of the things that we sometimes skip, point the finger at myself. I sometimes skip on these problems, making sure I've chosen a positive direction. Since I look at these two forces, this one's a little bit bigger. I'm going to make that the positive direction and this the negative direction. I'm going to add this little deal there saying, hey, overall to the left is positive. So now, what is the magnitude and direction of the acceleration? Well, I can say acceleration is the sum of all forces over mass. And if I put those values in, I can say acceleration is the sum of all forces. Well, that's the positive 17 newtons plus the negative 15 newtons divided by the mass, 0.2 kilograms. So I get acceleration is, well, 17 plus a negative 5, or pardon me, plus a negative 15 is a positive 2 newtons over 0.2 kilograms. That gives me an acceleration of positive 2 over 0.2, or 10 newtons per kilogram. And that's the same thing as saying the acceleration is positive 10 meters per second, and the positive means to the left. So one thing to be careful of here, the positive means to the left. Again, this is one of those spots where I would make sure I had positives and negatives indicated and I had a direction chosen for AP folks. For AP folks, it might even be worth saying 10 meters per second to the left. Our sign orientation and designating that stuff up like we did at the top should take care of it. There you go.